Let's take a look at the notation used with sequences. Now, a sequence is a function. We have that from our definition. So when we look at functions in an algebra class, for example, you might have f of x equals x squared plus 2. Sometimes you're given a domain, sometimes they ask you what the domain is, assuming that there's no restrictions other than the values that you're allowed to plug in for x. So in this case, we might say that the domain is the set of all real numbers. Now, we're going to change this notation a little bit because with sequences, the domain is not going to be the set of all real numbers. It's going to be some type of set of integers. So we're just using integers rather than all real numbers. So it's not going to be a continuous function, it's going to be a discrete function. All right, let's take a look at how we can change the notation here. Now, the name of our function is f, and when we're using sequence notation, we're going to use a usually as the name of the function. And instead of using the variable x, which normally does indicate that we're using real numbers, we're going to use n because that generally indicates that we're using integers. So I could write a of n equals n squared plus 2. And that's basically the same function. It would just depend on what the domain is. So we're kind of in transition here. I've kind of changed over to sequence though, so I'm going to say that my domain is the set of positive integers in this case. So that would be the set 1, 2, 3, and so on from there. But this isn't quite sequence notation. We've got a little bit of a change that we're going to do here. Instead of writing a of n, we're going to write this as a sub n. So the n becomes a subscript instead of something in parentheses. So we have a sub n equals n squared plus 2. Now you can see this notation would be awkward if n could be a decimal or some really long number, but as long as it's just an integer, it's very easy to use, and let's take a look at how we can use this. And again, I'll say that my domain is the set of positive integers. Okay, so a sub 1 is 1 squared plus 2, which is 3. A sub 2 is 2 squared plus 2, which is 6, and a sub 3 is 3 squared plus 2, which equals 11. So there you can see it works basically the same as if I said what is f of 1, what is f of 2, and what is f of 3. And that would come out to be the same, 3, 6, and 11. So the big difference here would be that you could actually find f of 1.5 and say that that was, let's see, 1.5 squared plus 2, which would be 4.25. So could we write that over here in the sequence notation? Could we write a sub 1.5? You could, but because our domain is the set of positive integers, we're not supposed to write that because we're only looking at values to plug in that are integers and not decimals. So that's sequence notation.